What if your power source was, well, alive? Today, we're diving into a really wild concept called the high bio panel. We're talking about a living material, one that's designed to generate electricity 24/7. This isn't just another panel, it's a blueprint for power that literally never sleeps. Think about it for a second. What is the single biggest drawback of solar power, right? The sun goes down and the party's over. This question right here is the whole ballgame. It's the one challenge this high bio panel is trying to solve once and for all. So let's break it down. On the left, you've got your standard solar panel. It's a sprinter, right? Fantastic when the sun is out, but it hits a total wall at night. That's called dead time. But over on the right, you've got the high bio panel. This thing is a marathon runner. It uses sunlight, sure, but it also has a microbial engine that just keeps on going. The goal here isn't a quick burst of power. It's all about continuous, reliable energy. And this is the part where you really have to shift your thinking. We're not just talking about a piece of hardware anymore. This is a living material. A symbiotic system where biology and technology are literally woven together to create a power source that just works around the clock. Okay, so how on earth does a living material actually generate power? Let's pull back the curtain and take a look inside this microscopic power plant that's running day and night. It's actually a pretty elegant three-step system. Think of it like a tiny, self-sufficient farm. First, a special top layer acts kind of like a pair of sunglasses, filtering the sunlight to just the right color for the algae living underneath. Second, those algae soak up that perfect light and photosynthesize, creating a constant supply of food. And finally, you have these amazing power-generating bacteria that eat that food and, as a byproduct, release a steady stream of electrons. And that's your electricity. Now, the heart of this whole operation is something called an electroactive hydrogel. Don't let the name scare you. It's basically a conductive jelly that's just packed with those power-generating bacteria. This is where all the magic happens. It's the little factory where the food from the algae gets turned into a continuous electrical current, whether the sun is up or not. Okay, so generating power 24/7 is one thing, but what happens when you need a sudden burst of energy? Or, what if it's cloudy for 3 days straight? Well, this panel has a super clever 3-layered storage system built right in to make sure it's resilient. So it's not just one battery, it's like a whole energy team, and each player has a special job. You've got the carbon aerogel supercapacitor. That's your sprinter, giving you an instant jolt of power right when you need it. Then there's the zinc battery, the marathon runner, which provides that steady, reliable power all through the night. And finally, for those worst-case scenarios, you've got the lithium microstack. That's your emergency reserve, the hero that kicks in during a long storm to keep everything running. So what can this living panel actually do? Let's get into the nitty-gritty, talk some numbers, and see where this tech could actually pop up in the real world. All right, get this number, 0.70. This is the target capacity factor. Now, what that means is it's a measure of how often the panel is actually making power. Your typical solar panel, it's only productive maybe 20–25% of the time. By working day and night, this panel is aiming for 70%. That is a massive, game-changing leap in productivity. And this table here gives us a look at the actual goals. The MVP column, that's the minimum viable product, kind of the conservative, we can definitely hit this target. And even there, it's making power at night. But check out the stretch goals column. That's where things get really exciting, with the potential for up to 20 watts per square meter at night. These are real, concrete numbers that show just how much potential is packed in here. So where might we see this stuff? Oh man, this is the fun part. The possibilities are just incredible. I mean, imagine greenhouse roofs that not only power themselves, but also create fertilizer as a byproduct. Or bioenergy skins for beehives to power fans and sensors that keep the bees healthy. We could even have smart clothes with this stuff woven in to power our wearables, or building curtains that are generating electricity long after everyone's gone home. It's a vision for a truly integrated, sustainable world. This all sounds incredible, maybe a little like science fiction. But how do we actually get from a cool concept to a real-world product? Let's take a look at the roadmap. They've laid out a really ambitious 6-month plan to bring this idea to life. It starts small, with just a tiny 10-centimeter tile, and then it methodically scales up. The goal is to go from a lab bench concept to a real-world test on a greenhouse roof, powering an actual fan in just 4 months. It's a clear step-by-step plan to make this happen. So is this all brand new science being invented from scratch? Well, no, and that's the really clever part. This chart shows something called the Technology Readiness Level, or TRL. It's just a scale from 1 to 9 that NASA uses, where 9 means it's ready to go. As you can see, the individual components of this system are already well on their way. This isn't about reinventing the wheel, it's about putting existing, proven science together in a brilliant new way. And this quote from the source material just sums it up perfectly. The HiBio panel is a theoretical integration of known subsystems. It's a huge visionary idea for sure, but it's one that's built on a solid foundation of real science with very practical uses already in mind. So we end on a question that kind of challenges our whole definition of technology. This concept, it really blurs the line between what we build and what we grow. It makes you wonder, is the future of power going to be found in bigger, more complex machines? Or is it about finally learning how to partner with nature itself? Maybe the most advanced technology is the one that's been all around us this entire time.